Okay, I want to talk a little bit more about functions here, and in particular I want to talk about working with functions and how to go about it wisely, okay? And also we'll look at a little bit at the TI 8084 calculator and how you can use that as well, and some of the useful tools that are on here, okay? So this is exciting. This will be fun. So I have a function. It's a quadratic equation, and I don't know how much you remember about quadratic equations, but we're going to learn some stuff about them as we do this. One thing is quadratic equations, which are like the ax squared plus bx plus c, right? You can solve them by using the quadratic formula, and we'll look at that in a minute. They always form a parabola, okay? And one thing we know is that if the leading coefficient is positive, it'll be a parabola opening face up, and if the leading coefficient is negative, it'll be a parabola going face down. Okay, so this is a parabola going face up, okay? And so of course, if you have an upward, let me just kind of draw a picture here. What the quadratic equation does, let's say I have a parabola going face down like this, right? These are the roots of the equation. So like f of x is equal to ax squared plus bx plus c. Okay, and if this is some parabola, this would mean that the a is negative. Okay, and the reason is because it's face down like that. And the quadratic formula, if you remember, is that the roots to this, and the roots are basically the x-coordinates that make this function equal to 0. And they are also where the function crosses the x-axis. Those are the roots of the equation, and you can use the quadratic formula to find those. And the quadratic formula is just, you take the opposite of b plus or minus the square root of b squared minus 4ac, and then all of that is over 2a, right? And that'll actually give you the roots of the polynomial. Another thing is, like, this is a maximum value. So a parabola, a quadratic equation, will either have a maximum value or it'll have a minimum value. So if it's open downward, then this is like a maximum value right here, okay? And if it's open upward, if the a is positive, then it'll have a minimum value at that point. And it's really easy to find that. This is just the opposite of b over 2a. That's going to be the x-coordinate, right? So what we could say is that the vertex of this parabola is, the x-coordinate is the opposite of b over 2a, and then the y-coordinate would be the function value of that. Okay, and you know what? I'm jumping ahead of myself a little bit because we haven't talked about that function notation, but we're going to talk about that next here. So this point here is f of the opposite of b over 2a, right? So the x value is this, and then you plug the x value into the polynomial, and you get the y value, and that would be, this ordered pair is actually that, and that is the vertex. So these are all very helpful things about quadratic equations. Okay. Let me zoom in on that. I think you can probably see it, but maybe I can zoom in like that. And if you want to pause the video and write that in your notebook, maybe you can keep a collection of facts that you kind of know are important, and you've learned before, but kind of have them handy, okay, somewhere in your notebook. So, okay, I'm going to zoom back out now. And so let me talk about that function notation. So this is function notation, f of x. And really, basically, y is equal to the f of x value. And so basically, let's say I want to evaluate this function, let's say at 0. Okay, so f of 0 is, and then in for my x, I would put in 0 for each time, like that, and then plus 8.95, and then these would go away, and I would just get like 8.95, right, like that, and I'm evaluating it, but what that means is 0, 8.95 would be a point on my parabola, and this would actually be the y-intercept, right, where x is 0, right? This one has a y-intercept down here, but this one, the y-intercept would be 0, 8.95. Okay, and you could do this like with any value. Like I might do f of -3, right? So now I'm going to plug in -3 squared minus 6 times -3 plus 8.95. And then I'm going to do 9. This would be plus 18 plus 8.95. Get my handy dandy calculator. So 9 plus 18 plus 8.95. And it's like I get 35.95. Right? And so it's like I'm evaluating this at -3, and so I get this ordered pair, -3, 35.95. That'd be another ordered pair in my function, okay? And so that's how that function notation works. And it's also important, you can use it, and we're going to be using it to do some other, we're going to use it to define a derivative, and you can use it for other things. But what you can do is you can put in not just numbers, but maybe what I'll do, and this is weird because these are x's, right? But I'll put in like x plus h, and basically what this means, okay, is I'm going to take the x is just kind of a placeholder. So I got something squared minus 6 times something plus 8.95. Okay, and so what I'm putting in for x, this is f of x, and you're putting x in for x, you would just get that same equation out. But what I'm going to put in for x here is x plus h. So I'd get like x plus h here, x plus h there, right? And then I could solve this, or I could simplify this. I'm not solving, it's not an equation. But, okay, this is binomial squared. So I've got like x squared plus 2xh plus h squared. Then I get like minus 6x minus 6h plus 8.95. Right? And so I get all this, and it's a big messy expression. Okay? And here's an interesting thing. Let's say I do f of x plus h minus f of x. Something like that. What this is saying is that I'm putting in x plus h into the equation. And then what I'm going to do is I'm going to subtract the f of x, and the f of x is just the equation, so x squared minus 6x plus 8.95, like that. And this actually reduces down pretty nice if I distribute that negative sign. So this thing we've already seen reduces to all that. And so I'm going to distribute the negative sign, so I get negative x squared plus 6x minus 8.95. And what you see here, hopefully you can see all this, but what you see here is a bunch of things are going to cancel out. Look at this, the x squareds cancel out. This does not. This does not. But the 6x's cancel out. This does not. And this cancels out. Okay? So anything with an h there didn't cancel out. So this thing really reduced down. Kind of nice. And basically, what I've just done here is I've done all the hard work in finding a derivative for this function. Okay? Which we're not going to do until chapter 3. But the point is this notation can be used to do all kinds of things. And so it's going to be a very important tool. Hopefully a lot of this is review and that you've seen it before. You may want to pause it and look through the work that I did. You know, basically, what did I do there when I square that? Basically what I'm doing is foiling. I did it real fast. Okay, I didn't show all the steps, but when you FOIL, first 2 gives you the x squared, outer 2, xh, inner 2, xh, and then last 2, h squared, right? And so this is x squared plus 2xh plus h squared. So this is what I did here, okay? And so there's just a lot of algebra. Look at how big, messy this can get. You know, it just expands all out. And then you got to be an accountant, right? You got to be very precise with what you're doing. You write out the steps. Don't just sloppily kind of, you know, just put a little here, little there. What you want to do is this, to really make sure you get it right, is make sure that this first thing and the next thing really are equal. In other words, if I actually put in something for x and h, I would get the same thing on both sides. And then this one and this one really are equal. And this one and the next one are equal. And this one and the next one are equal. So what you're doing, if you make sure each statement between each equal sign is equal to the previous one, then you know the final answer will be equal to your original expression. And that's the way that you can guarantee that you're going to get it right. And so learning to write this out is so important. Okay? Very important here. Now I'm not done though. I want to play around with this function a little bit. So I'm going to write it again. And so this is f of x is equal to x squared minus 6x plus 8.95. And so let's call this working with functions. And now let's put in wisely. Let's be wise about it, okay? So what do I mean by this? So when you are asked questions about this, like maybe graph this, or you might be asked, what is the vertex of this parabola? Or you might be asked, what is the roots? Or when does this equal 0? Or whatever it is, okay? So oftentimes we like to use we got this really great, amazing calculator. This technology is awesome. This little calculator does more than all the computers could do when they sent man to the moon for the first time. Okay? So if you go back and watch Apollo 13, that is a great movie. And one thing you notice is that when the accident occurs on the space shuttle, all the engineers are trying to figure out whether they can bring them home or not. And they don't bring out calculators to figure things out. They actually bring out slide rules, a slide ruler. Because that's how they did calculations back then. And the computers that they used filled up whole rooms. And the difference is they now have these microprocessors that all fit on a chip. In the past, they had to fit in a big room, and even then, our microchips are better than their huge computers, right? So you got some amazing technology here. Learn to use it. Be wise with this. Learn to use it wisely. And so what I mean by that, just don't like put in a graph and just kind of scribble the graph on there and assume that you know what's going on. You gotta actually work with the equation, maybe with a table, maybe with a graph, maybe do some algebra to see what's going on. But all these things go hand in hand. So there's three ways of working with functions, and those are numerically, and I kind of illustrated these in my last video, graphically and analytically. Okay, numerically is kind of like a table. I don't know if I'm going to be able to fit this. So this is a table. Graphically, you can write this in your notes. Graphically, that's your graph, of course. Analytically, this is your algebra and your equation, working with the equation. And they all go hand in hand with the software. So it's kind of like all of these work with the software, and they all work together. You don't just use the software and trust that you know, whatever this tells you is right or whatever, because there are things about the software you have to know, and little things that it can be misleading if you don't know about what's going on. Okay, and it takes time to know that. You will inevitably make some mistakes, you know, with using the software, but you will learn from those mistakes, and that's how you will get better mathematically. Okay, so let me graph this. So if you have your calculator, if you hit the mode button, there's actually 4 graphing modes on here, and they show up right here. There's function, parametric, polar, and sequence. And this class, we're going to always be using that. As far as I know, we're going to be using the function. So make sure it's set on that. And then up here you have this Y editor, so you can click on that, and it will bring up this Y editor. It'll bring up a place where you can put in different functions. Okay, so this is Y is equal to all this, so there's like Y1, Y2, Y3, those are different functions. So the Y1 could be like f of x, Y2, g of x, Y3, h of x, if your problem gives you 3 functions and calls them f, g, and h, which is a common thing. You'll see that. Okay, so you can put a bunch of, I think 9. It looks like you can put 9 different functions in here at one time and graph them all at the same time. And it even gives them all a different color. That's a new addition. When I was in college, they did have graphing calculators, but it was all black and white. But now they're in color. So that's kind of cool. So I put in the equation, and so let's graph it, okay? And if I hit graph, there's like a standard window. So if I hit graph, if I haven't done anything, and it just, let me actually go back. Let me change my window. No. Let me hit I'm just going to go square. Change it, and then I'll go graph. And I'll explain these in a minute, but I'll just do standard. So this is the standard window, okay, that your calculator uses. And so it looks like I got this parabola, and boy, it doesn't do a very good job. And maybe it's my screen. I actually have a little screen cleaner. I don't know if this will help. Don't want to mark on it. So, and I just don't want it to be, there we go. That's pretty good. So it looks like this parabola goes down, touches the axis, goes back up. That's what it looks like. Okay? And so the window here, this is the standard window. It's just -10 to 10. Okay? Now, and it's that way on both the x and the y axis. So you can change the window. Like if I want it to be -5 to 5, on my x-axis, but then I want it to be, let's say, negative 20 to 20 on my y-axis, right? Like that. So it can do that, and it'll look a little bit different. So now it's negative 5 to 5, and then this goes all the way up to 20, and it kind of makes the thing seem a little more stretched out, doesn't it? Okay. The one that really shows it without any distortion here is the z-square. And basically what that does is it graphs it sets a window so that the scale on both of those are the same width. So the screen is wider than it is tall, right? So if this is negative 10 to 10 and this is negative 10 to 10, then these units have to be smaller than those units. Do you get that? And so you kind of get a distortion. But this will set your window, so this is it. This is what you have to set it to, and the calculator will do it. Negative 32 to 32. And you know what? It might have went with my... Let me go to standard window. Wait 1 minute. I'm going to go back to the standard window. And then, and now let me go to zoom square. There we go. And so with the standard window, when it squares it here, the x has to go from negative 16 to 16, while the y's go from negative 10 to 10, because that's the ratio that it has to go. So the y's can't go as far as the x's, because the x's are wider here, right? Okay, so that's the square window. And you can do different things. Like I can zoom out then. Like I could zoom out by changing my window, right? But you can zoom out in this way. Zoom out, hit zoom out, and where do I want to center it? Maybe I want to kind of center it here. Hit that, and then hit... It's going to kind of center it so it zoomed out kind of where I was at, okay? And you could always do... When I do it, I don't move that. So let me go to standard. And then if I'm going to zoom out, this will zoom out for me. And I just hit return, return. I don't move that. That is if you want to zoom in or out on a certain piece of the graph, okay? But maybe I want to zoom in. I think this brings me back to the standard. And you could zoom in further if you wanted to. Another one that I really kind of like is this zoom box. And this is nice because then I can just make a box. So let's say I just want the bottom of the parabola, right? And so I'm going to hit like return and then just kind of go like this, and I'll get the bottom of the parabola. And this will become my new window. Okay? When I hit graph. No, oh, I must not have done it right. Let me try it again. I must need to hit Z box. So I make my box. I like this because you can just make a box the way, just like you want it. There we go. And don't hit graph. I think you hit enter again. There we go. And so now it'll do it just like that. See that? Now I zoomed in here. Do you notice anything? If you look really careful, if you're paying attention, this thing doesn't come down, touch the axis, and go back up. So maybe I'll zoom in once again, right? Zoom in right there. It actually goes down, back up. And so this did not come down, touch the axis, and go back up. And so it actually has two roots, right here and here, right? And the vertex isn't, this was 3, so it isn't 0, 3, like we thought it was. Okay, that's not the vertex. And so this is what I mean about working wisely with your, using the calculator wisely. These are very nice tools that you can use to help you work with functions. But you don't want to just rely on it and not know and understand the functions. So here's a couple things. For example, I can solve this and find the roots of this equation. And I can do that by using the quadratic formula. So it's going to be the opposite of b, so the opposite of -6 minus the square root of b squared, so -6 squared, minus 4 times a times c, all over 2a, 2 times 1, and this is plus or minus there. And so this would be 6 plus or minus, and this would be like 18 times, or 18 minus 4 times 8.95. Oops, something. 6 squared. I'm sorry. 36. I'm not sure why I said 18. 36 minus 4 times 8.95. So the reason I knew that I had made a mistake here was this was negative. And you can't have a negative underneath the square root. No, well, you can, but if you do, then you don't have real roots. You'd have complex roots. And what it would mean is it would mean the parabola would lie either above the axis facing upward or below the axis facing downward. Okay? But if it's going to have roots, then this has to be a positive expression, which it is. It's 0.2. It's very small, right? 0.2. And then this whole thing is over 2, right? So I got these two roots. X is equal to 6 plus square root of 0.2 over 2, and then x is equal to 6 minus square root of 0.2 over 2. So let me do this. 6 plus the square root of 0.2 over 2. So I'm using parentheses there. And I get like 3.22. So this is x is equal to 3.22. And then this one would be x is equal to x would be equal to, and now I'm going to put a minus here. And I get 2.78. 2.78. And if it's approximately here, if this is approximately, then I would put something like that there. Okay? And so basically these would be the roots. This 2.780 and 3.220. So by using the quadratic formula, I see that that is not just going down to the axis, right, and touching it and going back up. That's what I would have thought if I wasn't careful, if I wasn't using the equation, the calculator, everything all together. Okay? And so those are those two roots. Now the nice thing is I can actually find those two roots using the calculator as well. You got some neat tools on this calculator. So if I look at the Calc, see the Calc, second Calc, I get value, 0, minimum, maximum, where two graphs intersect, and these are derivative and integral, which is what we're going to be learning about in this class. So the value here just is, if I want to put in a value, like if I want to put in 3, so at 3, hit enter, it's actually equal to negative 0.95. That's what this says. So this thing goes down, or I'm sorry, negative 0.05 is what it actually equals. And so that would be a point on there. If I wanted to do, I could do like 2.9. That's a little bit over, and that's like negative 0.04. okay, and so on. And so you can evaluate the function like that. Another thing that you can do is you can actually find where the zeros occur. So I'm going to go to second trace. So I can find the zero of the function. So I'll find this one over here. If I go on this side of the intersection and hit return, I'm going to put one bound in there. If I go to this side and hit return, so I'm trapping that in between two bounds, and then I'm going to go in the middle to offer a guess and hit return, and then it actually gives me my root down here, 2.776 whatever, so it's a 2.78 rounded to 3 decimal places. Okay, and similarly you could find the one over here. So second calc 0. Now I can go to this side and do my left bound, hit return, do my right bound, hit return, do the middle, hit return, and there's my other one, 3.22. So it can find the roots here. Okay, very, very cool, huh? So now I'll hit second calc. So again, the calc is above the trace, so second calc. And now I can find a minimum or a maximum. This thing does not have a maximum, but it does have a minimum, and we know it's actually going to be at 3. Okay, so if I hit return here, and then I go to this side, hit return, and then go in the middle where it should be, hit return, and I actually get the value. Look at this though. This says 2.9999 repeating, and then negative 0.05. Okay? Again, this is one of the technology things, right? It's actually 3. It is straight 3. It's not really close to 3. And so the calculator can be, as it does its algorithm to locate that, it has a computer program, it can get slightly off and not give you the exact answer, when you could really get the exact answer if you know how to work with the function. So if you remember, like here's our function, 1, 2, 3, and this thing is really going down, right, like this. And if you remember, this occurs at the opposite of b over 2a. That's where the minimum is going to occur in this case. So the opposite of b, that's the opposite of negative 6 over 2a, and a is 1. And so this is going to be 6 divided by 2, which is 3. And then I can plug that back in. F of 3 we saw on there. It'd be plugging 3 in to here. 3 squared minus 6 times 3 plus 8.95. And we saw that that was equal to negative 0.05. Right? And then we can see that the vertex is 3, negative 0.05. Right? And that's this point right here, the vertex. Oh, I am so sorry. I just looked up, and I see that you couldn't see any of that. I got to be paying attention, don't I? Especially when I zoom in and out with the calculator. So what I'm doing is I'm actually showing you kind of how to find the vertex, right? The vertex is the minimum value in this case, and I'm using this formula, the opposite of b over 2a, and when I plug in, my b was negative 6 and my a was 1. When I plug it in, I do get 3. And then when I plug 3 into the function, I do get the negative 0.05. So I can use what I know about the equations and the math with the quadratic equation, the quadratic formula. I can use all of that to help me. Okay? Another nice thing that you can use, let me show you, is completing the square. And I'm going to do this on a back here. And this just plays a role in many things. Completing the square. And here's what I mean by this. X squared minus 6x plus 8.95. So to complete the square means I'm going to add something in and then subtract it right back out And what I'm going to add in and subtract out is going to be what I need to complete the square with these three numbers. And what that means is so that this thing will factor back down into a binomial squared. And the number that you put in when you're completing the square is always half of the b. Well, this is a simplified case where there's no leading coefficient. If there's a leading coefficient, you have to factor it out. And you can look at YouTube on videos on completing the square. But if it's no leading coefficient here, it's half of the b. Half of the b squared. So half of -6 is -3 squared would be +9. So I'm going to add that in, but then I'm going to subtract it right back out. So in other words, this expression is no different than this expression. Okay? Because if you simplified, this would just go away. But these can then be factored into x, and this is going to take the sign of this and then half of that. So x minus 3 squared. So this, when you FOIL it out, would give you that. And then this just becomes -0.05, right? And this is the standard form of a parabola. Okay, so if you remember, if this is y equals x squared, and we're going to look at this in the next section, is that inside, this tells you how you shift horizontally, and it's always, if this is -3, then I shift to the positive side. If this were x plus 3, I shift to the negative side. And then this tells me how I shift vertically, and then in this case, if it's a plus, I move up. If it's a minus, I move down. I know I'm going terribly, terribly, terribly fast, but this should be things that are review, but it's good to see it, and good to see how all these things work together, okay? So, when you work with functions, you can do it numerically, graphically, analytically. You can use rules that you know about that particular type of equation, quadratic formula, the opposite of b over 2a, and you're just using all of it together to really figure out what's going on. Okay, that's what you're doing here. So you're using it wisely. Now there's another thing. Let me go back to standard window. This is the last thing I want to show. And that is, you can actually make a table as well. Okay, so if I do the standard table, then I would just, the table is right above the graph button here. So second graph. And this is a table. And you can see these are x values, and they're going up by 1. 0, 1, 2, 3, 4. And you can see that the 3 is like the -0.05. And then you can scroll down, and you can just go on and see numerically the x and the y values. Okay? You can also change the table, and this is kind of like zooming in. Let's say I want to zoom in right around 3, right? So I'm going to stop on 3, and then I'm going to hit second window, and that's my table set. And so so what I want to do is I want to start at 3, let's say, but I want my table to go up by 0.1. Okay, and then if I go graph, second table, there you go. And now it makes a table. So now it's starting at 3 and it's going up. And so you can see there that it's like negative, 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 and then it goes positive. So it's right there between 3.2 and 3.3 that it crosses the x-axis, that it goes from being negative over here to positive, right? And so what I can do is I can then, I'm going to start it on 3.2, and I'm going to go up by 0.01. Okay, so in other words, second table set, and I'm going to go to 3.2, but then I'm going to go up by 0.01. So this table step is oops. Uh-oh, this is going to take a minute there. Okay. So I'm going to hit second. And so what I've done, the table step tells me now I'm going to start at 3.2, then I get to 3.21, 3.22, 3.23, and you can see that it's 3.22 is when it's negative, 3.23 is when it's positive. So it's in between those two. And I could zoom in and have my table step 0.001 and keep zooming in. And that's one thing that we're going to play around with when we talk about limits, because a limit is looking at what the function is doing around a certain point, not at the point, but as you approach that point and get closer and closer. Okay? And so that this feature of the calculator is really, really nice for doing that sort of thing. And this is how you could investigate the function numerically. Okay? Graphically would be like quadratic formula or whatever. Numerically is using this table function to look at the behavior. So before they had calculators like this, they would have to think about making that table every time you wanted to zoom in. It would be a lot of work. And you wouldn't even have a calculator to help you make the table. So those men must have been very, very smart. Smarter than me. Much, much smarter than me. Okay? So there's a lot of stuff here. Okay? Working with functions wisely. Unfortunately, the online homework doesn't go into a lot of this detail. So I've taken you further than what you need in order to do the homework here. But these videos are to get you thinking about actually working with the equations, with the graphs, with the tables, with the calculator, but not just depending on the calculator mindlessly. Okay? I'm really trying to show you this is what math is all about. This is people that go on and do engineering and stuff. You know, they write out, they take, you know, their time, spread things out. Even though it gets big and messy, they keep going. Simplify it down. Okay, that's what it takes. So these videos are a little longer, and in fact this one is much longer than I thought it was going to be. I thought this would be like a 10-minute video. It ended up being a 40-minute video. And so I apologize about that, but there's a lot of stuff here, okay? Even other things, other review, okay? So the other videos here, we're going to talk about stuff that you're going to be doing on the homework, and they include finding domain and range, working with piecewise functions, and then some of the applications, okay? And that's what we will look at in the next several videos. And I will make sure that these are much, much shorter. So these are just some introductory videos here. So I hope you enjoy them. I hope they're helpful.